For those of you that were away last class, we spent about 45 minutes going over the Chapter 2 test. If you did poor and you weren't here on the Friday, if you come in either tomorrow after school or Wednesday after school or Friday, yes, Friday after school, I can go through with you in detail. I can't. Thursday after school, I'm reffing right away, although I got about 10 minutes before I have to ref. You can come by right away. We said this. Turns out, all compounds can be classified as either organic or inorganic. What do you need to know? I'm going to put a little red star next to things that are important. Those of you that are away, you can put a star and fill in these blanks. Organic compounds contain carbon, and usually hydrogen. Oh, except there are some exceptions. Anything that has covalent carbon dioxide, we call these oxides, carbides, all contain carbon, but those are inorganic. So an organic compound has to contain carbon, usually contains hydrogen, but not every carbon is automatically organic. Over half of all known compounds are organic. We talked about carbon. Courtney, we said one of the nice things with carbon is it requires 4 bonds, and so almost always it will bond covalently, which is why it doesn't have an ion charge on your periodic table. It almost never forms ionic bonds. It can, but basically never. Much like everything that I'm teaching you, Lydia, everything I'm teaching you is technically wrong. Representing organic compounds. We said that the first way is the molecular formula, CH4. This is called methane or methane if you're British. 1 carbon, 4 hydrogens. It's called carbon tetrahydride if you wanted to go with the covalent name. But this is actually a type of gas. These have special names. We said that you can show also via a structural diagram. This shows you how the carbon is bonded to the 4 hydrogens. The problem is this is inaccurate because it's flat. In real life, Alex, these organic molecules are 3-dimensional. So there's something called a ball and stick diagram made up of little tiny balls and sticks. And this looks a bit better. It's 3-dimensional, but these are really, really hard to draw. There are whole kits that you can buy, Julia, little modeling kits to build these with. If we had one more day, I'd bring them out and we'd play with them. We don't have. If Friday was a day 1/3, we'd use them on the Friday, but I don't have time. Then there's these space-filling diagrams. I will not ask you to draw one of these or one of these on your test. I might give you one of these to recognize, hey, traditionally black is carbon, traditionally other colors are used for hydrogen. And we left off right here. I wrote down here, open to page 245 and get out a blank piece of paper, or you can use the back of your notes. Is the back of your notes completely the back page blank? So use that. Now, if you don't have a textbook handy, I've also copied it here, but it's worth having page 245 open. And it looks an awful lot like this here. Okay, so open to page 245. Do you have your textbook? You're good. Textbook here, Matt, or no? If you do, get it out. If not, I've got it here, but you got to squint because I can't make it very, very big. Page 2, under the B, 2, under the I, 4, under the N, 5, page 245. And what this activity is looking at is different ways that we can model or write an organic compound. You ready, Jasmine? So it says this. The following diagram shows 4 ways of representing methane, which is CH4. The first, the one that we're all familiar with, is the molecular formula. As a structural formula, each one of these is a covalent bond. So each one of these represents, remember, Sage, 2 electrons. So how many electrons does this hydrogen have with 1 covalent bond? What does that line count for? How many electrons? 2. Hydrogen is happy. 2. Hydrogen is happy. 2. Hydrogen is happy. 2. Hydrogen is happy. How many electrons does carbon want to have? What row is it in? It's in the second period, which has 8 electrons. 2, 4, 6, 8. There is a lovely little structural diagram. Allison, if I wanted to draw it 3-dimensionally, it would be like that. my ball and stick model, or in a space filling model where you have carbon, hydrogen, and these clouds, these clumps are supposed to show sort of the electron clouds overlapping. I can't draw those to save my life. I won't even try. What we want to look at, and this is a question I'm going to give you on your test, so I like this question, I like this question, I like this question. I'm going to give you a ball and stick diagram on your test and say, hey, tell me the formula. So it says, the following shows ball and stick models. I think I can make them a bit bigger. Yes, I can. For ethane and propane, flammable gases. Propane we use in barbecuing all the time. It says, A, give the molecular formula for each compound. Okay. Here's ethane. How many carbons? 2. Ethane has a formula of C2, and this is what you can write on the back page of your notes. You can put a little 2A, C2. How many hydrogens? H6. Do I reduce? No, it's covalent. Covalent, I don't reduce. I don't write that as C1H3. Looking at this ball and stick model, what's the chemical formula for propane? How many? 3. H8. That's the molecular formula. That I'll ask you to give me on a test. Then there's something called a structural formula. I won't ask you to give it to me on a test. I will ask you to recognize it on the test. Let me give you the structural formula for ethane. Ready? It looks like this. CH3CH3. This is part B. Can you see how I came up with that? The first carbon, how many hydrogens does it have on it? 3. You're showing that that carbon has 3 hydrogens. The second carbon, how many hydrogens does it have on it? 3. Another way to write ethane, if you want to write the structural formula, Dylan, if you want to show how it's put together a little bit more, is like that. Let's try doing propane. So you ready? The first carbon, Dylan, how many hydrogens does it have on it?
3.
So I would go CH3. There's a middle carbon.
2.
H2. There's a final carbon. H3. There is a structural diagram. I think if I gave you a structural, not diagram, structural formula, I would say, Alex, it's fair game if I give you this for you to recognize, oh, that's actually C3H8 in disguise. So I won't ask you to give me the structural formula, but Julie, if I give you the structural formula, I may ask you to recognize what it actually is. Is that okay? Yeah? There's the space filling diagrams for ethane and for propane. By the way, you'll notice the CHs, flammable. So methane, flammable. Ethane, propane, butane, these are all different types of, all gaseous and all very flammable. We use them in industry all the time. Number 3, you can write down on the back of your sheet a little 3. There are 2 different organic compounds that have the formula C4H10. Draw 2 different structural formulas for C4H10. I'm actually going to draw the covalent picture. How many carbons here, Taylor? So the first thing I went, well, maybe I have a carbon tucked with a carbon, tucked with a carbon, tucked with a carbon. Maybe all 4 carbons are in a straight line like that. Each one of those lines is a covalent bond. How many hydrogens do I need to fit in? And each carbon wants how many covalent bonds? 4, because each covalent bond is worth 2. 2 times 4. There's 8. So I said, well, maybe I want to go H, H, H. Does the first carbon now have 4 covalent bonds? How many hydrogens have I just drawn, Allison, in red? 3. 2 more, but not 3 more, because that would be 5 bonds. 2 more. And then that's one way to, that is a way to pair up 4 carbons and 10 hydrogens and have everyone happy. There's another way, it turns out. And this is why organic compounds get so complex, is you can have the same. This is why, Alex, for organic compounds, we actually sometimes go to that structural formula, because I'm going to draw something that has the same chemical formula. It's going to be a C4H10. By the way, what would the structural formula of this guy be? The first C has what? 3. The second C has, oh, sorry, not C3. C has 3 H's. The second C has 2 H's. This third C carbon has 2 H's. And the fourth carbon has 3 H's. There's another way you can write this, it turns out. Like this. This also works. How many carbons? 4, so that part works. Let's fill in the hydrogens by Joseph given every carbon 4 bonds for a total of 8 electrons. So I'm going to stick a hydrogen here, 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 here. How many H's do I have so far? 7. How many more do I need? Can I fit 3 on that bottom carbon? This is also, turns out, C4H10, but it has very different chemical properties than the other one. Hydrogen here, here, here. What would this structural formula look like? Well, C, how many H's on the first C? 3. Then C, how many H's on the second C? 1. So I wouldn't put a 1, I just CH. Then I have a C with an H3 and a C with an H3. Point being, this is why, Matt, were you here last day? The reason I said there are more organic compounds than all the rest of the compounds combined together. Not only can you have different chemical formulas, but the same chemical formula can be a totally different molecule. And that's all I wanted to talk about in that activity, is to show you Alex, who's not looking at his phone foolishly. We can draw these in different ways. Back to our notes. So, okay. Am I going to ask you to draw those on your test, Jeff? No. Would I have no problem giving you one of those pictures and saying, tell me the formula or the structure? Well, no, I said I wouldn't ask you to tell me the structural diagram, but tell me the chemical formula. Yeah, count the C's, count the H's. Recognizing organic compounds. This absolutely is on your test. First of all, if it doesn't have carbon, it's inorganic. Acids, inorganic, right? HCl, no carbon. Bases, inorganic. NaOH, no carbon. Salts, inorganic. Oh, carbon means organic except. Organic except. As a carbonate, so if it's a CO3, that's a polyatomic ion from the back of your sheet, Duncan, that's not an organic. And I guarantee, as a multiple choice question on your test, one of them is going to be, which of the following are organic? And I'll have one of them does have a CO in it. As carbides, if it appears after a metal and it's behaving like a nonmetal, so aluminum carbide, or as an oxide, carbon dioxide, carbon monoxide, if it's bonded with an oxygen. Those are not organic compounds. So Sage, I can't just say always with a carbon organic, but those are the exceptions. And yeah, I'll probably give you a question and the exceptions will be there to tempt you to say, oh, carbon, organic. No. You can usually recognize it because hydrogen is usually present. In fact, this year, Allison, almost always. So there's your other hint. If you see a carbon but no H, be wary. Be very wary. Okay? By the way, H not written first. So the hydrogen appears. Why wouldn't we want to write it first? In what type of compound have we put an H first traditionally and used that to recognize what it was? Okay, so this is to distinguish it from acids where the H is first. Not written first. If you see a C and an H, we're good. Hydrocarbons. Hey, what do you think hydro is short for on our periodic table? Hydrogen. What do you think carbon is not short? Oh, you know what? This one is pretty easy to figure out from the word. Guess which two compounds hydrocarbons contain? Contain C and H. There are thousands because carbon can form long chains. There are thousands. Okay? So the simplest one we said was methane, which was CH4, but then you can go 2 C's and have a hydrogen, 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 hydrogen. But if you want to, Taylor, instead of putting a hydrogen there, you can add another carbon and have hydrogens there, there, and there. Hey, stick another carbon, have hydrogens there, there, and there. Stick another carbon, and we have the technology. We can make those thousands of carbons long. Most of those end up becoming very, very cool gases that explode, like propane, butane, or plastics. This is some of what goes on in oil refineries, or refineries in general. So the simplest is CH4. What have we called CH4? Methane. Whoop. Now it moved suddenly. Simplest is methane or methane, depending on whether you're British or North American. So I've told you propane, I've told you butane, I've told you ethane, methane. What do they all have in common? They burn very, very well. These compounds are used as fuel. And they produce carbon dioxide and H2O. Wait a minute, Mr. Dueck. How can C and H give you oxygen in their final products? Where do they get the oxygen from? The air. Okay? This is why engines or burning stuff, you need oxygen. This is greenhouse gases. This is why when we burn hydrocarbons, one of the byproducts, water, not too bad, carbon dioxide, which is a greenhouse gas. Turns out, the larger the molecule, the more easily it becomes liquid. Okay? Methane, ethane, propane, and butane are gases, but in particular, propane and butane can be pressurized into a liquid. Anybody here done any grilling on a barbecue? That propane tank is liquid propane under pressure. When you open the valve, the propane depressurizes and comes out through the barbecue as a gas that's flammable. Butane, like the butane, little butane curling irons and things like that, that's liquid butane in there. Does a nice little burn. Hey, that's how you get it hot. In fact, it turns out pentane, which is moving one further up, already is a liquid at room temperature. So here's a chart. Let's see if we can fill in the blanks. I stole this from your text, but I don't think we need to go to our text. I think we can figure it out. So, what would, if I gave you this, what would the molecular formula be for that, for methane? CH4. Let's move down. Let's fill in this column. What would the molecular formula be for ethane? C2H6. What would the molecular formula be for propane? C3H8. And then I gave you butane as C4H10, and I gave you pentane. Pentane is already liquid at room temperature. It's C5H12, and we can keep going and going and going. And they all have different names, but I'm not going to make you memorize the names. The one I'm going to make you memorize, methane, which I've already flogged last class and this class. What about the shortened structural formula? Well, this one is CH4, because there's one carbon attached to 4 hydrogens. Here, how many hydrogens is the first carbon attached to? So CH3 and then CH3. Right? What would the shortened structural formula be for propane? CH3. Go ahead. CH2. CH3. And it keeps going. Courtney, where do we use this? So methane is used often in natural gas heaters. Methane is natural gas. Ethane, used a lot in manufacturing plastic. Propane, barbecues, camp fuel. Butane, handheld lighters contain butane because butane barely needs to be under any pressure to go liquid. So even that little plastic lighter can handle the pressure. Propane, you need to have like a metal container, a strong container, or it could crack and that would be dangerous. Butane, no. But if you do ever have a lighter that cracks, a little plastic one, toss it and be very cautious. It's giving off butane, it's flammable, and there could be a cloud of butane around it that could burn if you flick it, and it could actually catch your clothing or something like that. And then pentane. There's a pattern. Can anybody spot the pattern and see what C6 would go with? What about C7? So here's my question. What would C11 go with? Now, you've been going up by 2. Can you spot a way to turn a 2 into a 6, a 3 into an 8, a 4 into a 10, Taylor? Double it and plus 2, it turns out. So C11 would be H24. Double it and plus 2. Do you need to know that? Well, it's nerdily cool. I'm not going to make you memorize it, but I'm a math teacher as well. Cool pattern. And the fact that you were able to predict a compound. Kind of neat. Reading check. Write your answers in the space below. We're going to do these together right now. Number 1. I think there's space, is there not? So how about in the space below where I said write your answers in the space below? Hey, what element must be present for a compound to be considered organic? Carbon. Is that guaranteed that it's organic? No, but it can't be organic without that. 2. What other element is almost always present in an organic molecule? Three. Says list 3 carbon-containing compounds that are inorganic. Okay, I can do that. Carbon monoxide. Anything that ends in, what's carbonate from your anybody have their periodic? CO3. How do I make it small? Home. There we go. And now I need to undo that, Mr. Dueck. Click. Also what? Al4C3, where the carbon is acting clearly like a nonmetal. type because my handwriting is so atrocious. 4. Hey, list 3 inorganic compounds that don't contain carbon. Oh, easy. How about NaCl, salt? H2O. I'm going to avoid subscripts because they're. How about NaOH, OH? How about HCl, hydrochloric acid? Hey, any of the acids on the back of your pink sheet? Those are inorganic. Is vinegar inorganic? That contains a carbon and a hydrogen. Okay, I fibbed. Vinegar is an organic compound, which is why they write the C first as chaku. And now you know. So not every single acid is inorganic, but the ones that start with an H are. Oh, and then hopefully easy marks. What 2 elements are present in a hydrocarbon? H and C, C and H. You know what? Let's go C first because that's how I wrote. Because in the carbon, C appear, and the hydrocarbon, C appears first, H appears next. Okay. Yeah, turn the page. Alcohol. And I'm not just talking about the type that you swallow or imbibe, and most of you are far too young for that, and it's bad for your growth, so I'll give you a little lecture. Don't drink. But anyways, there's a whole range of compounds, and they have very, very useful uses. So it's an organic compound that contains, well, it's organic, so it has to contain that. What else do most organic compounds contain? H. Leave a space for a comma. Put the H there. I'm doing it for a reason. And if it's organic, it contains carbon, it contains hydrogen. What makes it an alcohol is it also contains oxygen. Mr. Dueck, it would be wonderful if there was an easy way that I could remember that alcohols, Alex, look up. It would be wonderful if there was an easy way that I could remember that alcohol contains carbon, oxygen, and hydrogen. If you were a good teacher, Mr. Dueck, you'd have some simple, easy way that I could remember that alcohols contain carbon, oxygen, and hydrogen. Yeah, I got nothing. Sorry, I suck. Which is why I wrote it in that order, by the way. What are some types? Well, methanol, ethanol, and yes, methanol is similar to methane with an oxygen. Ethanol is similar to ethane with an oxygen. Propanol is similar to propane with an oxygen. They all kind of build on those hydrocarbons. So, molecular formula. Oh, hang on, I haven't done that yet. Solvents. Disinfectants. So hospitals use alcohol all the time, isopropyl alcohol, to sterilize instruments. Kills germs and bacteria very, very well. Ethanol is an inebriant. What's that a fancy word for? If you're inebriated. Okay. That ethanol is the one that's in what we call drinks. Okay. There are other types of alcohol that people do drink. Most of those are more toxic. Ethanol is toxic as well, but your liver can usually handle small amounts with it. But you've all read that you can die of alcohol poisoning if you drink too much, right? Ethanol can also be used as a fuel. Or they've started in the past 15 years adding it to fuel, so as a fuel additive. Ethanol is what you get from corn, moonshine, to be quite honest. But you can purify it, you can process it. So in the U.S. and in particular in Brazil, they're looking at trying to use ethanol as their main form to get away from the drilling for oil. They want to see if you can grow oil. Well, right now it takes, as I understand it, more oil to grow the corn or the sugarcane than you get from it, because you've got to pay for like the tractor to plow the field and all that stuff. So we're not breaking even yet, but maybe we will. Hey, what would the molecular formula if I give you this for methanol B? C, I agree with, not H3. How many H's grand total? 4. How many O's? 1. If you bond an oxygen to methane, you get methanol. Generally, we go carbon, then hydrogen, then oxygen, just so all of our answers look the same. So CHO. Yeah. And you can even see where we add it. That final carbon, we break its bond with hydrogen, and we stick oxygen right in the middle there. Ethanol would be C2H, how many? 6, O, 1. Isopropyl alcohol, this is what you also have in your medicine cabinet called rubbing alcohol. So this is what you put on muscles when they're sore or whatever. You awake, Julia? Sit up, we're almost done. What would this one be? C, how many C's? 3. How many H's? Count carefully. 8. O. And you can see that's a different way to bond them together. That's what gives rubbing alcohol its unique properties. So methanol is often used as a paint solvent. Turpentine has some type of alcohol in it. Ethanol, used as a camp fuel. And isopropyl alcohol, rubbing alcohol, used as a sterilizer, as a cleaner. Yep.
What type of wine is the one that people drink?
Ethanol is the one that you'll find like in wine or beer or those. But you hear stories of people who are addicted drinking paint thinner or solvent. They're getting methanol, which will also have a similar effect on this part, but it's way more, it's terribly toxic, and it can also do damage to other parts of you. And again, even ethanol, it's toxic. I'm not saying don't drink. I'm not saying never drink. I am saying don't be an idiot, which far too many teenagers are. Maybe some of you or you know of your peers. You don't seem to, as a group, moderate yourselves very, very well. And so I'd be a bad teacher if I didn't at least say, give your head a shake and be careful. Isopropyl alcohol, I mean, again, you can drink it, but I think that is much more poisonous and might be toxic, not just for the fact that your liver can't process it, but there's other stuff in there as well. Someone a question?
What do they use with the alcohol forming viruses? Like which one of those?
I suspect ethanol, but I'd have to look into it. He's asking, what do they use like in the, for the dragsters? I think in Formula One, I think it's methanol, because one of the issues with methanol is it burns invisibly. And that's why in Formula One, if you watch a car accident, all of a sudden after the accident, you might see people jumping around and smacking because they're on fire, but the flame is invisible during daylight. You can't see it. And so they'll be, this is why they bring up the fire extinguishers and they just spray it everywhere, because you can't tell you're burning until you're in pain, right? Yeah. Oh yeah, it burns with a colorless flame. Hey, what's an easy way that I can remember that alcohol contains OA and H? So a good test multiple choice question, Matt, would be give you 4 things. Which of the following are alcohols? You're looking for it has an OA. It's a hydrocarbon with an oxygen attached. Okay. And that's why we always start out looking at hydrocarbons and then move into alcohol. I was going to do page 249. I'm not going to bother. Instead, I'm going to modify this Chapter 5 review. First, I'm going to give you the organic chemistry homework. So the words in the middle that you can barely read on your copy are ethanol, hydrocarbons, inorganic compounds, and methane. They're barely legible, but they are. Yes? The photocopier, for some reason, was doing weird stuff. You can read those okay? Are there any of the questions that you're looking at and you can't read them? I'll show you them and you can fill them in, but I think they're legible, but just barely, yes? What about on the next couple of pages? This page here? The next one? Okay, so first of all, this one here, recognizing organic and inorganic compounds, absolutely questions like this on your test and on multiple choice. Should go pretty quick. The next page?
Yeah, this one's pretty cool.
Can't even see most of them?
Well, you can see.
Can I see, please?
Number 6.
Okay.
Number 8. Holy
So for now, I'm going to reprint this page. I'll come get it. I'll send it to the photocopier, and I'll reprint this. I think I can get a good copy now for you guys. And you can just staple it onto the back, because the answers are attached. You can do everything else for starters. And then I said I was going to modify this big, huge review. So right now, at the bottom of your notes, I've said do this. I think this is going to be overkill. So let me look at this. Bear with me for a second. Page 251. Page 251. So let's do this. Page 251. Here's what I'm going to assign. I think 2 is good. Four through 6 is good. 7 is good. 4 to 7. Careful. And 11. And then from page 252. This is kind of a review of everything. So what did I say? Yeah, 1 is good. 2 I'm going to skip. 3 I'm going to skip. 4 is good. 6, actually, you know what? I'm going to go 4, 2. 5 is good. 6 is good. Yeah, let's pause there. Skip 7. Skip 8. It's kind of cool, but I'm going to pass. 9 is good. 11 is good. Skip 12. 13 to 15. Then I said 16 to 23. Let's see, that's a lot. Okay, I'm going to go 16 and 17. Skip 18. Okay. Well, you're going to get lots of time next class and lots of time on Monday. These are going to be due, I think, the day of the test. This is part of your studying for the whole unit. Okay? Going to give you a bit more. So this is mandatory, and then I'm going to say, if you want more practice on balancing equations, try page 252, number 19 to 20, 19 and 20. This is what I'm going to, that last part, Dylan, I want to spend Wednesday really going over and really hammering home. I'll put together a practice sheet. Okay? So organic chemistry homework. Also, if you have any missing assignments and you want them on term 1, you can work on those. I was hoping to give you a full half hour. I'm going to give you 25 minutes to work on the homework. I went a little bit longer than I planned. Okay? Right click.